V1I represent? Look at that. V2I minus V1I is the velocity of approach. The V2I minus V1I is the velocity of approach. And what does V2F minus V1F represent? V2F minus V1F is the velocity with which they move away from each other. We call it the velocity of recession. So, one more time, V2I minus V1I is the velocity of approach, and V2F minus V1F is the velocity of recession. And what we have here is velocity of recession is negative of the velocity of approach. Now that's an important quantity in collisions. That means for an elastic collision, this is for an elastic collision. For an elastic collision, the velocity of recession, that means the velocity with which they move away from each other, is negative of the velocity of approach. So V2F minus V1F is the velocity with which the two objects move away from each other, and we call it the velocity of recession. And V2I minus V1I is the velocity of approach. Therefore, we make this statement: for an elastic collision, the velocity of recession is the negative of the velocity of approach. For an inelastic collision, now can this equation be modified for an inelastic collision? Yes, we're going to write this with a small modification. For an inelastic collision, the same equation will read like this: V2F minus V1F equal to negative E times V2I minus V1I. The velocity of recession is negative of a constant times the velocity of approach. And this E has a great meaning in objects colliding. E is called the coefficient of restitution between the two colliding objects. So, E, the coefficient of restitution, can now be written as E equal to V2F minus V1F divided by negative of V2I minus V1I. Velocity of recession divided by negative of the velocity of approach. Okay. For an elastic collision, what is the value of E? E is 1. Is that right? For an elastic collision, E is 1. And for an inelastic collision, that will be less than 1. For a perfectly inelastic collision, what is a perfectly inelastic collision? A perfectly inelastic collision is a collision where after the two objects collide, they stick together and move together as a single body. I have actually shown that to you once. Let me show you an example of a perfectly inelastic collision. But before I show you that, what is the value of E for a perfectly inelastic collision? E equal to 0. What does that mean? When E equal to 0, the right side is 0. It means the velocity of recession is 0. They will not be moving away from each other. They will be sticking onto each other. There will be no velocity of recession for a perfectly inelastic collision. Remember our truck hitting a car, and the truck and the car becomes one object? That is an example of a perfect inelastic collision. For a perfect inelastic collision, the value of E equal to 0. That means the velocity of recession is 0. Okay. Now the collision between these two cars, watch the collision between these two cars. You can see this is almost elastic. Almost elastic. velocity of approach equal to negative of the velocity of recession. Is that right? Yes? There you are. Whereas, let me show you another example where after collision the two objects stick together as one object. You have actually seen this. I'm going to fire this ball into the pendulum. The ball is going to collide with the pendulum, and what happens at the collision? Well, there you are. After collision, the two objects got stuck together and they moved as a single body. So in this case, it is a perfectly inelastic collision and the velocity of recession is 0. Well, you can actually look at collisions in many spheres. Now, I have an object here. I'm going to drop it into this container, and the base of the container is actually steel. So this ball is going to collide with steel. Tell me, if the collision is elastic, what is it that you would expect? If the collision is elastic, there will be no energy lost. That means if I drop it from this height, it must rebound to the same height. But look at this. Most of the energy is lost in that collision. It is a very pitiful inelastic collision. On the other hand, I have a small steel ball here, and watch how this behaves. Can you see this? Now that came almost to the top. You can see here, one more time. It rose up to here. That means it lost very little of its kinetic energy. But still the collision is not elastic. It is inelastic. Well, look at another ball. Well, it lost more than half its energy. That means each of these collisions has a value of E which will be between 0 and 1. Is that right? Okay. So, for an elastic collision, E equal to 1. For a perfectly inelastic collision, E equal to 0. And for most other collision, E has a value between 1 and 0. Let's now talk about kinetic energy in a perfectly inelastic collision. Well, if objects after collision stick together and move as a single unit, the collision is perfectly inelastic. Alright? A trolley of mass m1 is moving with the velocity v1i, collides with a trolley of mass m2 initially at rest, means v2i equal to 0. They collide. After collision, they stick together and has a mass m1 plus m2. Here I have shown that they are sticking together. They have a mass m1 plus m2 and they move away with a final velocity vf. If Ki is the kinetic energy before they collide and Kf the total kinetic energy after they collide, then I can write Ki equal to Pi squared over 2m1. Do you remember in the last class actually we showed that momentum, kinetic energy can be written using momentum. Kinetic energy 1/2 mv squared is the same as P over 2m. So the initial kinetic energy is only the kinetic energy of the first object. The second object has no kinetic energy. So Ki is Pi squared over 2m1, where Pi is the initial momentum of the two objects. And Kf equal to PF squared over 2 times m1 plus m2, that is the total mass there. And Pi equal to Pf, that means Pi squared is the same as Pf squared. Why? Because in all collisions, momentum is conserved. No matter what kind of collision you consider, initial momentum is always equal to the final momentum. So Pi is always equal to Pf. Therefore, final kinetic energy divided by the initial kinetic energy will be, let me write that down for you. If you want to find the final kinetic energy divided by the initial kinetic energy, it will be Pf squared over 2 times m1 plus m2 times 2m1 over Pi squared. Did you understand that? I want to divide the final kinetic energy by the initial kinetic energy. This quantity divided by this quantity. Dividing by a rational expression is the same as multiplying by the reciprocal. So I took Pf squared over 2 times m1 plus m2 and multiplied it by 2m1 over Pi squared. Is that right? And now, since Pi equal to Pf, these will cancel. The 2 and 2 will cancel, leaving us with m1 over m1 plus m2. And that gives us a very important result. And what does that result mean? When two objects of masses m1 and m2 collide and they join together and move away as a single body, the ratio of the final kinetic energy to the initial kinetic energy is m1 over m1 plus m2. Okay, let's do a problem. A freight car with a mass of 2 times 10 to the 4 kilogram rolls down an inclined track through a vertical distance of 3.3 meter. At the bottom of the incline, on a level track, the car collides and couples with an identical freight car that was at rest. What percentage of the initial kinetic energy is lost as a result of the collision? Alright, let's picture that problem. For a perfectly inelastic collision, we obtained a ratio of Kf over Ki. What is that ratio? Kf over Ki is m1 over m1 plus m2. Now, in this case, the two cars are of identical mass and this is the mass of one car. Therefore, m1 plus m2 will be twice that value. So, m1 plus m2 equal to 2m1. So, what is Kf over Ki equal to? 1/2. That means, in this particular case, the half of the original kinetic energy is lost. So what is the percentage of energy lost? The percentage of energy lost is Ki minus Kf, that is the amount of energy lost divided by the initial amount of energy multiplied by 100. That will be 1 minus, you see, divided by Ki. Ki divided by Ki is 1 minus Kf over Ki. 1 minus Kf over Ki multiplied by 100. And Kf over Ki is 1/2. So this will be 1 minus 1/2 multiplied by 100. That is 50%. 50% of the original kinetic energy is lost